All right, so in this section, we're going to talk about double angle and half angle formulas. Um, we have just a couple different rules or formulas that we can use, and they're going to determine how we can work each and every problem and everything based off of what we're given. So for our rules that we're going to look at, for our double angle formulas, we got sine of 2 theta is equal to 2 sine theta cosine theta. Cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And this is going to be our most common form of cosine 2 theta. Because if we notice down below, cosine 2 theta actually has 3 different formulas that we could use for it. Because cosine 2 theta can be cosine squared theta minus sine squared theta, or 2 cosine squared theta minus 1, or 1 minus 2 sine squared theta. And how we know which one to use, which one's the easiest, that'll depend on what we already know about our problem and our triangle. Because if we already know a cosine, we use the second one. If we know a sine, we use the third one. If we happen to know both of them or can see it really easily, we use the first one. But in all cases, we should get the exact same answer. For tangent of 2 theta, that is equal to 2 tan theta divided by 1 minus tangent squared theta. So all of these make a big difference in terms of what we're given will determine how we use each one of these. In order to prove these, we could use Pythagorean identities. We could use, eventually we could use derivatives, but that is for the next class, so we don't really know that yet. So in this one, it says, use the following figure to find the exact value of the following sine of 2 theta. So we know that sine of 2 theta is equal to 2 sine theta cosine theta. So given this right here, we have 2 times sine of theta is 3 over 5. Cosine of theta is 4 over 5. So when we do this, we get 24 over 25 as our answer here. So pretty easy. We already knew everything on our triangle. It was easy to pop it out. So for our next example here, use the following figure to find the exact value of cosine 2 theta. So for this one, it really doesn't matter. So we'll use all 3 to show what we have here. So we're going to go in order for the way we just saw them. We're going to use cosine squared. So we have 3 cases. We have cosine squared theta minus sine squared theta. Then we have 2 cosine squared theta minus 1 and 1 minus 2 sine squared theta. So that's our 3 forms. So we're just going to go in order. So cosine of theta, or alpha in this case, so cosine alpha is 24 over 25 all squared minus sine squared, which is 7 over 25 all squared. So really, we have 24 squared minus 7 squared over 25 squared. So pulling up our calculator. So this is 576 minus 49 over 625. So this is 527 over 625. And I don't think that will reduce. It will not. So that's what we got when we did the first case. So let's do the second case there. 2 times 24 over 25 all squared minus 1. So we end up with 2 times 576 over 625 minus 1. So this is 1152 over 625 minus 625 over 625, which gets us 527 over 625. Again, the same answer. If we do the last one, 1 minus 2 times 7 over 25 all squared, which is 1 minus 98 over 625. So 625 minus 98 is 527 over 625. 3 different formulas, all 3 give us the same answer. So it doesn't matter which way you do it. So for this next case, we're given cosine of theta is 10 over 26. Theta lies in quadrant number 4. So if we draw this out, so cosine of theta is going to be 10 over 26. So we need to solve for that last side. So we get a 24 here, a negative 24. So make sure you keep it as negative. Just so we don't have to worry about anything, let's go ahead and let's see that sine of theta is equal to negative 24 over 26. Cosine of theta was given as 10 over 26. And tangent of theta is negative 24 over 10. Now, let's find everything we need. So sine of 2 theta is 2 times sine theta, so negative 24 over 26, times cosine theta, which is 10 over 26. So if we were to do this, we would get negative 480 over 676. You can reduce it if you want to. This would become negative 120 over 169. Cosine 2 theta. Since we were given the cosine, just to make sure that everything's right, I would probably use the second one there. So that's 2 times cosine of theta all squared minus 1. So you'd get 200 over 676 minus 1. So negative 119 over 169 would be our answer there in simplified form. Tangent of 2 theta. There's a couple different ways that we could do this. We can use the formula here. So we'll actually do both real quick. So 2 times tangent of theta, negative 24 over 10, all divided by 1 minus negative 24 over 10 all squared. So negative 48 over 10 divided by 1 minus 576 over 100. So we get negative 48 over 10 divided by negative 476 over 100. This would reduce to 480 over 476. Which is going to give us 120 over 119. If we look back up here at what our sine of 2 theta is and our cosine of 2 theta, notice if we divide them, we get negative 120 over negative 119, which is 120 over 19. So that's the other way you could have done this once you know sine 2 theta and cosine 2 theta to find tangent 2 theta. I would only do it that method if I'd already found sine 2 theta, cosine 2 theta. Otherwise, I use my formula. So we're told use the given information to find the exact value of cosine of 2 theta, given that cotangent of theta is in the third quadrant. So basically we know that tangent of theta is equal to 1/4. So that's what this means, is that tangent of theta is equal to 1/4. So tangent of theta is -1, -4, which means that my hypotenuse here is going to give me 17. So cosine 2 theta, it doesn't matter which one we use. Let's use the last one because I don't think we've used it yet. So cosine 2 theta is 1 minus 2 sine squared. In this case, sine is going to be -1 over square root 17, all squared. So that's 1 minus 2 over 17, which is 15 over 17. So we're told, write the following expression as the sine, cosine, or tangent of a double angle, then find the exact value. So something to note here, theta equals 112.5. We're in the form 2 sine theta cosine theta, so that means that we have a sine 2 theta, which means that this is the sine of 225. Sine of 225 degrees is going to be -√2 over 2. So we're told use a double angle formula to find the value. And we don't know what 7 pi over 12 is. That's not anything that's on our standard unit circle. So in this case, theta is 7 pi over 12. 2 cosine squared minus 1 gives us that this is cosine 2 theta. So this is cosine of 7 pi over 6. And the cosine of 7 pi over 6 is going to be negative square root of 3 over 2. So really, we're just making sure you know your forms frontwards and backwards here. So we're going to write the following as a tangent of a double angle because it's all got tangents in there, and then find the exact value. So in this case, theta is pi over 8. So tangent of 2 theta is tangent of pi over 4. So tangent of pi over 4 is the value of 1. So we're just trying to make sure that you can see it and understand it both ways. So that was how we can do our double angle formulas. Now we can talk about our half angle formulas that we'll finish out this section with right here. So our half angle formulas are a little bit more complicated in what we have to do with them. And I say that in terms of we have a square root. So sine of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha all over 2. Cosine of alpha over 2 is equal to plus or minus the square root of 1 plus cosine alpha all over 2. Tangent of alpha over 2 is equal to plus or minus the square root of 1 minus cosine alpha divided by 1 plus cosine alpha. Now, we will not have two answers. The plus or the minus is determined by the sign of the trigonometric function. Plus or minus. So based on the quadrant in which the half angle lies will tell us which one it is. So in other words, for sine of alpha over 2, we need to see where is the sine, what is the value, what's the sine of alpha over 2, for the angle alpha over 2 in the quadrant that alpha over 2 is in. So that's where we got to kind of go back to which quadrant is positive for sine. So in other words, for sine, if we are in the first and second, that means it's positive. Third and fourth gives me a negative. For cosine, that's going to be first and fourth gives me positive. Second and third gives me negative. For tangent, tangent is going to be positive in the first and third. And then the second and fourth, it's going to be negative. So that's what we kind of have to keep in mind whenever we see those right there. And this means that this is all for alpha over 2 in those quadrants, in each one of these cases here. Now, tangent does have some other forms. They are a little bit different in terms of what we're looking for. So we just have to be careful with that, because depending on the type of problem will depend on which formula you use. Honestly, if they give it to you where tangent has a square root in there of some sort, so a weird angle of some sort, then I would probably use one of these two. Otherwise, I would jump to the main form up there. It all just kind of depends on what you're given and everything. So we're told use the half angle formula to find the sine of negative 22.5. So what that means is that alpha over 2 is equal to negative 22.5. That means that alpha is equal to negative 45. We care about this one. In this case, they're both going to be in the same quadrant, so it doesn't matter, because this tells me that this is in the fourth quadrant. So with this being in the fourth quadrant, so that means that sine of I like writing mine like this, negative 45 over 2 is equal to, so fourth quadrant, sine is going to be by our rules right here. So fourth quadrant means that sine is negative. So this is negative the square root 1 minus cosine of negative 45 all over 2. So minus the square root. Cosine of negative 45, well, cosine in the fourth quadrant is positive. So this is going to be 1 minus, so cosine of negative 45 is root 2 over 2, all over 2. Obviously, we want to simplify this as much as we can. So this is negative square root of 2 minus root 2 all over 4, which means this is negative 1/2 on the square root of 2 minus square root of 2. I know it looks ugly, but that's what we're going to have to end up with in some cases. So we're told use the half angle formula to find this value. So that means that alpha over 2 is 157.5. That means that alpha is equal to 315 degrees. So what that means for us is that tangent of 315 over 2 is equal to, if we don't want to have to worry about what we're doing here, why don't we use one of the other ones here? So if we did 1 minus cosine 315 all over, not over 2, over sine 315, this should give us the same answer as sine of 315 over 1 plus cosine 315. So let's check them and see. So cosine of 315 degrees, that's a fourth quadrant. So 315 is 7 pi over 4. So this is going to be 1 minus square root of 2 over 2 over negative square root of 2 over 2. So this is going to be 2 minus square root of 2 all over negative square root of 2, which is the same as root 2 minus 2 over square root of 2. If we did this one, this would have been negative square root of 2 over 2 divided by 1 plus square root of 2 over 2. So we do that, we get negative root 2 over 2 plus root 2. We could, in a sense, we could check to make sure these are correct by actually foiling this out, multiplying by the conjugate and everything to show those two are equivalent. The harder one to show that's equivalent is the third case here, and that is if we did, so 157.5 is the second quadrant, so that means that it's negative. So if we did negative square root 1 minus cosine of 315 over 1 plus cosine of 315, we get negative the square root of 1 minus root 2 over 2 divided by 1 plus root 2 over 2. So we end up with negative square root of 2 minus root 2 over 2 plus root 2. And then we have to multiply by the conjugate inside of there to show that it's equivalent to the other two. So it's a little bit more detailed process to show it than it is in the first two cases. All right, so we're given cosine of alpha over 2, or we want to find cosine of alpha over 2 given the following. So we need to find our last side here of our triangle. So using the Pythagorean identity, we can figure out that this last side is 25. So for cosine of alpha over 2, based off of the figure, we can see that all of these values would be positive. So therefore, this is equal to the positive of the square root of 1 plus cosine of alpha all over 2, which is equal to 1 plus, so cosine of alpha is 24 over 25. all over 2. So this is equal to the square root of 49 over 50, which is 7 over square root 50, which is 35 root 2 over 2. No, let me put a little more thing in there. So we get 7 root 50 over 50. Square root of 50 breaks down to 5 root 2. So this is going to be 7 root 2 over 10 would be our answer here. So we got different ways that we've seen different values and everything. So we just need to make sure that we're careful in following our formulas and understanding that each formula has specific cases that we can do, especially like in the half angle with the plus or minus. We have to make sure that we are using the correct one, because we will not have 2 answers for each one. We only have 1 answer. So just make sure that you are keeping up with all of that.